All right, this is 2007 FRQ number 6. The f to be the function defined by f of x k times root x minus natural log of x for x greater than 0, where k is a positive constant. Find f prime and f double prime. So part A is very straightforward. You're just looking for f prime and f double prime. Trying to save paper, so yeah, I'm going to try to squeeze my work in here. All right, so f prime of x is equal to, k is a constant, so we leave a k there. X to the root x is x to 1/2, so times 1/2 x at negative 1/2 minus natural log of x is 1 over x. All right, so I'm gonna clean this up a little bit because it'll help me write my, find my next derivative. So I have k over 2 root x minus 1 over x. That would be my first derivative. All right, second derivative, actually this is good for later. So second derivative, I'm gonna use this. So k at 1/2 is still my constant, so k over 2 is my coefficient, times now the derivative of x to negative 1/2, so times negative 1/2, x to negative 3/2, and then 1 over x is x to negative 1, so minus, bring down a negative 1, plus x to negative 2. So this is really negative k over 4, x to 3 over 2, plus 1 over x squared. So that would be my second derivative, okay? Part B. For what value of the constant k does f have a critical point at x equals 1? Well, that means that when I plug in 1, I should get 0 for the first derivative, because that means that's what the critical point means. It's an extrema, and extremas will have, that's how we solve for extrema, is when the first derivative equals 0. So it says at x equals 1, I have a critical point. That means that when I plug in 1, I should get a 0. For this value of k, determine whether f has a relative min or relative max or neither x equals 1. Justify my answer. Well, let's figure out what k is at that point. All right, so if x equals 1, I have a critical point. That means this equals 0. All right, well, let me rewrite it so it makes a little bit more sense. It means that f prime of 1 equals 0. Right, that means that when I plug in 1, I should get 0. Okay, so I get 0 equals k over 2 root 1 minus 1 over 1, which gives me 0, k over 2 minus 1, add the 1 over, k over 2, k equals 2. Okay, so for this value of k, does f have a relative min or relative max? So the quickest way to figure out if it has a relative min or max is to take that and plug it into the second derivative. So now you have k, and you have x equals 1. You just want to know at the second derivative, if my answer is going to be positive, then it concaves up. If my answer is negative, then it concaves down. If it concaves up, you have a minimum. If it concaves down, I have a maximum, right? So a second derivative is very useful in this case. So I'm going to go f double prime of 1. I know x equals 1, and I also know k equals 2. So negative 2 over 4 times 1 to the 3/2 plus 1 over 1 squared. All right, so that gives me 1 to the 3/2, doesn't matter, 1 to any power is 1. So you get negative 2 over 4 plus 1, negative 1/2 plus 1 gives me a positive 1/2. So because it's positive, it's greater than 0, this is going to concave up. Hence, I have a minimum. All right, so you will say then, because it concaves up, x equals 1 is a minimum. Okay, part C says for a certain value of the constant k, the graph f has a point of inflection on the x-axis. It gives us two really important information. When function has a point of inflection, that means the second derivative is equal to 0. So part C says f double prime of x equals 0. Then it says it's on the x-axis. If it's on the x-axis, it's going to have a y value of 0. That means your original function is going to equal 0. So up here, for some x value, my f is going to be 0, right? So f equals 0. Okay, so second derivative, you have 0 equals negative k over 4 x to 3/2 plus 1 over x squared. And then you also have the fact that your function, 0 equals k root x minus natural log of x, right? You have two variables, you have k and x, therefore you need two equations to help you solve. All right, so if we move this over, you get k over 4 x to 3/2 equals 1 over x squared. All right, let's cross multiply. So you get kx squared equals 4x to 3 halves. And you are solving for k, so k equals 4 times x to 3 halves over x squared, which is going to be, if you take 3 halves, subtract the 2, you get 4 over x to the 1 half, which is 4 over root x. All right. Then you use this equation, you get natural log of x equals k root x. And then solve for k, you get natural log of x over root x equals k. So now you have both of these equal to k. You can set them equal to each other. So you get 4 over root x equals natural log of x over root x. The denominator is the same. Just set the top equal to each other. 4 equals natural log of x. To get rid of natural log, take e of both sides. X equals e to the 4th power, right? But it's not asking for x. It's asking for k. So now you got to pick any of the equations and plug it in. Maybe easier to plug it into this one, right? So k equals 4 over root x, which is 4 over e to the 4th square root of that. So that's 4 over e squared. So that's your k value. Okay, that's it.